everyone, and welcome to week 1 of an introduction to paleontology with the Safe Cultural Heritage Group. I'm your mentor, Jenna. In today's lecture, you will be learning about what paleontology is and dispelling some common misconceptions about it, the fossil record and how fossils form, notable figures in paleontology, the geological timescale, and phylogeny. What is paleontology? Paleontology is the study of all ancient life. However, it excludes the study of anatomically modern humans, which is us, and our activities, as that becomes archaeology. There are numerous different branches of paleontology, all of which kind of interlink with each other. So we've got vertebrate paleontology, which is the study of organisms with a backbone, like we do, like we have, as well as most other animals. The study of invertebrate paleontology, which is the study of organisms without a backbone, such as those trilobites. Ichnology, which is the study of trace fossils, so they are the traces of organisms left behind, such as burrows, trackways, feeding traces. We've also got micropaleontology, which is the study of microorganisms such as foraminifera, plant pollen, spores, diatoms, etc. We've also got paleobotany, which is the study of ancient plants, as well as palynology, which is the study of plants and plant fossils, spores, and pollen. So that does come under micropaleontology. We also have paleoenvironments, paleoclimate, and paleoecology. So what is a fossil? A fossil is the remain of an ancient organism that is preserved within geological strata. This could include skeletal remains, which is what we most know a fossil to be, such as bones, teeth, as well as sometimes soft tissue. We also include fossils being tracks, trails, borings, eggs and feces, as well as impressions. There are, however, other types of fossils known as permafrost fossils, so this is where an animal sort of gets mummified, which we can see in these absolutely stunning fossils, such as this woolly mammoth calf and this woolly rhino. Many misconceptions in paleontology, most of which have arose from films such as Jurassic Park. So the first one being it's all about dinosaurs. No, not really. We've kind of already covered this. It is such a wide range of things that are studied in paleontology, so it isn't just about dinosaurs, it's about everything else. The dinosaurs in Jurassic Park are scientifically accurate. No, not really. Some are, some aren't. For example, velociraptors, they were in Jurassic Park, these big dinosaurs, but what actually happened, they were about the size of a turkey. And what instead in the film they used this fossil called Deinonychus, which is a velociraptor relative, and just scaled it up and called it a velociraptor. And as well as this, the Dilophosaurs, we don't have any evidence of them spitting venom. That's a bit of a weird one, but yeah. Fossils are always found as complete specimens preserved to perfection. No, not really. It's such an amazing thing that happens if fossils are complete specimens, but however, usually it is just like an isolated bone here and there. All organisms get fossilised. This is not true. I'm going to talk about this in a bit, but not everything gets fossilised. It has to be kind of right place, right time. So yeah, paleontology and archaeology are the same. No, so bits of archaeology does border on paleontology and bits of paleontology border on archaeology. So for example, Neanderthals can be classified as both archaeology and paleontology. Paleontology, although is a study of all ancient life, it doesn't include our anatomically modern humans and our activities. Mammals didn't evolve until after the dinosaurs became extinct. This isn't true. Mammals were around at the same time as the dinosaurs. However, they were much smaller than what we expect today. Just kind of little shrew-like animals, as well as kind of getting up to the size of a cat. You are just like Ross from Friends. This is a kind of how to annoy a paleontologist 101. I get this so much. all the time. It isn't really like that. Ross doesn't is I don't know how to explain it. He's not really that great a paleontologist. And as much as paleontologists like to drink coffee, probably not the same amount as Ross. All dinosaurs lived at the same time as one another. No, this isn't true. So we are going to talk about this more in our dinosaur lecture, where we discuss about the 3 different kind of time periods that dinosaurs lived in. And for example, T-Rex was closer in time to us than it is to Stegosaurus. So those are 2 dinosaurs, but with the amount of millions of years between them, it's just crazy to think that they are like often shown together, but they weren't together in real life. Paleontologists just dig randomly and hope. So no, that's not true. Paleontologists, what we do is we usually look for localities that would have the kind of type of rock that we need, as well as the age of rock that we need. Alongside this, sometimes we do just dig randomly and hope, but it's usually quite well planned that we do go out to the field and plan field expeditions for that. And every Mesozoic reptile is a dinosaur. This isn't the case. So in the Mesozoic, it is called the reign of the dinosaurs, but we also have ichthyosaurs, pterosaurs, mosasaurs, for example, loads of different reptiles that also were around at the same time as dinosaurs. They are nowhere near dinosaurs on the phylogenetic tree. It's kind of like a sister taxon, really. And then finally, it is all old white men. This was the case, but more recent years have shown a more general increase of women in paleontology and a few more POC people in paleontology. How does a fossil become a fossil? So step 1 is to die in a good preservational environment. Step 2 is that all the soft parts, which include muscles, skin and organs, decay and or get scavenged upon, leaving behind only hard parts, which include the bone, shell and teeth. And then on top of this, layers of sediment begin to form. So step 3, sediments build up on top of the organism, putting a lot of weight and pressure onto the layers below, which compresses the fossils. The sediments then lithify, which is what, like the sciencey way of saying turns into rock. So number 4, whilst this is happening, the hard parts of the skeleton are being replaced by minerals that harden to form fossils. And then step 5, through the processes of erosion as well as excavation, the fossils become exposed for collection by paleontologists. Our record is heavily biased. For example, 60% of organisms in some marine depositional environments have no hard parts, and the likelihood of hard part preservation has changed over time. So this means that in the environment, 60% of those organisms that are there would not get preserved in fossils. So we would only get the ones that would have the hard parts, so the other 40%. There are some biases in the fossil record, so this includes taphonomic, which is the way in which the fossil decays. So this could be environmental, geological, the organism itself, which includes size, its anatomy, the abundance of the fossil organism, the geographic range and the temporal survival, as well as preservation potential. And then also there are other biases that are inflicted upon the fossil record, which we do, which is anthropological. This includes a field bias, the acquisition, curation and preparation bias, so academic versus commercial collecting. So academic collection is when researchers go out into the field and do a dig there and take the fossils back for studying, whereas commercial collecting is where people go out and collect these fossils and then sell them on via usually the internet. There's also a type of science called parachute science, which is where researchers, primarily white, from a Western country go into a country that is not so well developed, etc., and do the study of the fossils, take them out and take them back to their Western country. Alongside this, there is the study and publication bias, which includes does this organism really have that much potential to be studied and publicised? So, for example, you're more likely to want to read a paper on T-Rex or Spinosaurus rather than one on a fossil fish. Alongside this, there are political biases. So, for example, countries that are at war, there isn't that much funding to go to do fossil excavations, as well as funding. To talk about Lagerstatten, which are locations that usually have pretty good preservation of fossils. So the word Lagerstatten is a German word, so Lager, which means storage, and Statte, which means place, and it just kind of smushed together means storage place. And it represents a snapshot in time. There are two types. There is the Konservat, or the conservation Lagerstätte, which often has exceptional preservation and most of the time has soft tissue preserved, whereas a Konzentrat, or a concentration Lagerstätten, has a high abundance of fossils, but it doesn't mean that they're exceptionally well preserved. We're going to go through some examples of Konservat Lagerstätten. These are absolutely beautifully preserved fossils, so they range from all around the world really. So we've got some in Canada, which is known as the Burgess Shale. We'll be talking about this next week in the Cambrian explosion lecture. We've got the Solnhofen limestone in Germany, the Posidonia Shale in Germany, and Grubenmesel in Germany. So all of these localities have different time periods attributed to them, as well as the Green River Formation in the USA. We also have this amazing fossil formation in China, which is known as the Yixiang Formation, and as well as, this is another picture of the Posidonia Shale. So these are just beautifully preserved fossils. Lagerstatten are localities that have high abundance of fossils. So this includes the Hunsrück slate in Germany, where although they are pretty well preserved, there's just a huge abundance of them. Riversley in Australia, which is a cave deposit where quite a lot of organisms fell into the caves and formed these really well preserved cave deposits, so it means that they're all a bit scrambled, but yeah. And then one of the most famous examples of a Konzentrat Lagerstatten are the La Brea tar pits in the USA. This is home to Smilodon, Mastodon, and the American lion. And although these specimens are beautifully preserved, so it could be classified as a Konservat Lagerstatten, there's also just this huge abundance of fossils found there. For example, the image on the bottom right, which is the La Brea Tar Pits Museum exhibit of direwolf skulls. And that's just only a few of them, there's so many of them. About some notable figures in paleontology. So it used to be predominantly white men, and it has been changing. This more recently, there is a general shift towards more women and more POC people being involved in paleontology. Through some notable figures. We have George Cuvier over here, who is typically known as the founding father of paleontology, and what he did was he created this thing called comparative anatomy, where he compared bones of living animals with those of extinct animals. William Buckland was the first person to write a full account of a megalosaur, which was the first dinosaur to be found. We also have Richard Owen, who coined the phrase dinosaur, which means terrible lizard. We have the Bone Wars, which was between Nathaniel Charles Marsh and Edward Drinker Cope. So these two American paleontologists set out to find the most dinosaurs. Franz Nopska, he is a eclectic personality, I would say. He was a paleontologist from Eastern Europe, and he his life story is just crazy. I would definitely recommend reading up on him. And what he did was he found this fauna in Romania, which he named the Hatzeg formation, and these fossils show evidence of insular dwarfism. So this island, as it would have been in the Mesozoic, had sauropods, which were typically massive organisms, such as your Diplodocus and Brachiosaurs, but they were small compared to what they should have been. And he's also found the remains of Haxagopteryx, which is a pterosaur, which was about the size of a giraffe. We also have Mary Anning, and she was one of the only women paleontologists back in the back in the last few centuries, and she worked primarily in this place called Lyme Regis over here in Britain. And what she did was she found loads of fossils of marine reptiles such as ichthyosaurs, plesiosaurs, and sold them. And she's the inspiration to the rhyme "She sells seashells on the seashore." So there are loads of other notable figures of more recent times, but these are some key ones that I think you should all know. On to the geological timescale. I know that from this image it can look really daunting, so what we do is sometimes explain it in terms of a geological clock. What works is that we use a 24-hour clock to show key times and events. Begin at 12 AM, the Earth forms, which is at 4.6 billion years ago. Life, known as single-celled prokaryotes, evolve at around 3:30 AM. Photosynthetic organisms merge. The atmosphere becomes oxygen-rich, and it forms the first snowball Earth at around 2.3 billion years ago. Single-celled eukaryotes arrive. 4 PM, multicellular life forms appear. The first aquatic animals are found. PM, animals start to make their way onto land, following plants that had made this transition at around 9:30 PM. 40 and 11:40 PM, dinosaurs rule the Earth. 2 minutes to midnight, our very first ancestors split off on the hominid evolutionary tree. Modern humans, aka us, arrive just as the clock turns midnight. A bit of perspective onto these. We, as paleontologists, geologists, and anyone who works in timescales, we talk about eons, eras, periods, epochs, and ages. So an eon is a large division of geological time, which is the largest, and it comprises of numerous eras, which is roughly a duration of 500 million years or more. So an example of an eon is the Phanerozoic. An era is the first order of geological time, which is composed of several periods, and these roughly last several 100 million years. And an example of an era is the Cenozoic. A period is the second order, and it is composed of hundreds of millions of years. And an example of a period is the Quaternary. A epoch is the third order, and these are roughly tens of millions of years in time. And an example of an epoch is the Pleistocene. And then finally, an age is the fourth order of and it's roughly in millions of years. And an example of an age is the Cambrian. So we also might talk about chron, which is an extremely small unit of geological time. But usually this isn't used as much as age. So to run this through, we are in an example would be the Cambrian age of the Pleistocene epoch of the Quaternary period of the Cenozoic era in the Phanerozoic eon. We'll talk about phylogeny. Phylogeny is the relationship between all life on Earth that has descended from a common ancestor, often represented as trees, with the root or the base of the tree being the most ancestral lineage, and then the tip of the branches are the most recent descendants. And as you move up the tree, you are moving forward in time. And when a branch splits, so for example, where the yellow dot is, it is known as a speciation event. Types of phylogenetic tree. The first one being a monophyletic tree, and this includes the most recent common ancestor and all of its descendants. And this is also known as a clade, and an example of a monophyletic taxon is Mammalia, which is the mammals. So for clades, they are a grouping which include a common ancestor and all of its descendants of the said ancestor. So for example, the top two are good examples of clades because they both have the most common ancestor and all of its descendants, whereas the bottom two show a common ancestor and then some sister taxon to it. A paraphyletic taxon is a collection of organisms including the last common ancestor but not all of its descendants, and this can't be a clade or a monophyletic group. So this includes Dinosauria, fish, for example, have the Polyphyletic taxon, and this does not include the common ancestor of all taxon members. Polyphyletic taxa are considered unnatural and are usually reclassified so that they fit within a monophyletic or a paraphyletic taxon tree. And these are usually the result of a convergent evolution. So for example, flying vertebrates, so they all have wings, which include the bats, the birds, and the pterosaurs. They're not all within the same clade, because bats are mammals and birds and pterosaurs are classified as reptiles, but they're completely different, and because they are flying, that is a convergent evolution. We'll be going through an example of a phylogenetic tree. So cats and humans both have a backbone, whereas butterflies do not. The backbone is, or the vertebrae, are known as a synapomorphy, which is a derived or specialised character state that originated at their last common ancestor. DNA is shared between all of these creatures, and this is known as a plesiomorphy, which is an ancestral or a primitive state. Butterflies have an exoskeleton which is made of chitin. This is known as an apomorphy, which is a derived or a specialist character, or tapomorphy, which is an apomorphy which is unique to a single group. Here's the further reading, if you want to, of course, and I will pop these on a Google Classroom post for you guys to all be able to access. The references for this talk. This lecture is on the Cambrian explosion. So in this we'll learn what it was, its key dates, paleogeography and paleoclimate, the key fauna, key localities, and the trigger/stroke causes of this explosion. Thanks for watching this week. You can find Say Cultural Heritage Group on all of these, and you can find me on all of these links as well. So yeah, look forward to seeing you all next week. Bye!